Hello, this is my final project video for Mr. Osway's class. Today we're going to be working with a wind tunnel. I'm going to be doing all three. And to start it off, just open up this design model really quick. And then we can get started with designing this. I'm going to be switching tabs from Google to this so I can see the dimensions, because they're real specific. But yeah, sketching. Just gonna draw a couple of lines and dimension them really quick. It's pretty good. Now we need to go over here, the middle one. There we go. H2. There we go. Then we have H3. Perfect. Zoom in a little more. We're going to go back to draw really quick so we can center it. We're going to draw a line that goes above the whole thing. And then we're going to draw a construction point on the origin. Then constraints, midpoint the line with this. Perfect. Set right in the center. Can zoom a little more. Alright, next step. I'm going to draw 4 vertical lines. Perfect. And we're gonna midpoint all of those and dimension them. Let me just do that really quick, and then actually we'll dimension them first. Just give them the dimensions. And then we can move them. Constraints. There it is. Point to midpoint. Perfect. Now, where are they? Here they are. More dimensions. There we go. Okay, now we can kind of just draw the outline of the whole thing and delete all these lines in the middle because you don't need those anymore. They're useless now. But yeah, we can just kind of just delete that. All these. Delete. I think you got all of it. Nothing else. Alright, now we can just draw. Line tool. Not bad. There we go. There we go. I forgot to delete 2 more lines. Yep. Delete these middle ones, we don't need these either. Okay, perfect. There it is. And now, before we continue, I'm gonna go to the workbench. I'm gonna update what we've done. And then I'm going to copy paste this. So I'm gonna duplicate it. And duplicate it again. Perfect. Just so we can kind of make this a little bit easier for ourselves. Now we can go back. We're good. We just need to update it and duplicate it. Now we can continue where we were. So we need to generate this surface, because the first one is just empty. Nothing else. Boom. There you go. That's all it is. You can go to the next step for this one. And we can mesh. I think all the meshing is like the same, pretty sure. Yeah, they're all the same kind of thing. You just do the same kind of thing. Let's go over here. We can insert the first one. Do a method mesh. Triangles. Oops. Triangles. Go ahead and generate that. I think I finished. There we go. And the next thing we're going to do is you're going to click on mesh, and we're going to go to element size. We're going to put that to 0.01, I think. Yeah, or in meters, that makes sense. There we go. And then we can generate that. This one just takes a little bit longer. Okay, that's the meshing stage done. Now we need to name our edges. So we go to edge. I'm control left clicking every single wall. Perfect. And then press N. It's the wall tunnel. Sorry. We'll do wind tunnel wall. Wind tunnel wall. And then over here. And then one more. That's all of them. There's nothing in the inside for this one, so we don't have to name anything. Usually you'd name the cylinder or the plate, but we're done. Now, you can go to the next step. We can update that real quick. Open up the setup page. Dial precision to, I'm going to close both of these because we don't need to do these anymore. Not until we finish this really quick. Alright, and then we start. We're in. Almost. Okay, we're in. We're good. Cool. Alright, we'll start it off. Go to models, energy, on the viscous, keeps on. Okay. There we go. Those are all things you gotta do there. Now we go to our boundary conditions. My bad. We go to our boundary conditions, velocity inlet, and to set, Osby wanted the test section to have 15 meters per second, and so I just I did like A1 V1 equals A2 V2. I got the velocity that it should be in the beginning, and I got it was 4, and then I tried it out, and it actually, was pretty close. It was very close to 15. I think I just went a little bit over, but I just put it at 4, and that should be fine. Apply that, close it. All the walls should just not be moving, so shouldn't be a hassle. Stationary, it's all good. Close that. Now we can just initialize this. Initialize. Perfect. The calculation. We don't need that many iterations for this one. Not a lot is happening. It's just the air going through the wind tunnel. And calculate that. Now, we do need to get the contours, which we'll get after this is finished. We'll do it all right here, and then we can go move on to the next one. The contours, the streamlines, and that center line stuff, and the vertical center line plots. Well, that goes. Let's see exactly what we needed. Hold on. Yeah, pressure, velocity, total pressure dynamic, streamline, along the center line, and okay, then plot the direction. Okay, we can do that. We got that. Should almost be done. Well, I was thinking about cutting this, but I'm not going to cut anymore because I kind of just waited it out. So, anyways, now we're done with that. Graphics, contours. Let's get our contours really quick. So we're going to select all of them. This is the regular pressure contour. We can do it right now. That's what we get. There you go. Nice. We can do the velocity one. There we go. Nice. See, it kind of like barely gets to 15, like 1.49 at the very tops and bottoms, like here at the edges. It really gets close, but it's almost there. Back to pressure. Now we do total pressure. Total pressure one, and then we can also change it to dynamic pressure and get that right there. Perfect. Now we can go to the streamlines. We go to path lines. We need to put this on, not density, oops, velocity. We're going to do just velocity inlet, take less time. And we can say this way out. Now, here we have the path lines for the velocity. Pretty cool. Pretty cool. Oh, now you can move, thank you. There you go, it's pretty cool. Anyways, now for the XY plots. So, this one, we need to make a new surface. We need to make new lines. So, we need to make a center line that goes in the very middle. Now, the way I drew mine, so you drew it like, kind of just like in the middle of both, on the X and Y, and we midpointed it. We can just do, because we just add the whole thing up and then divide it by 2. We do negative, which is the first part, and the second one. And that should be fine since you're already in the drawing. We don't need to change this. It can be 0, 0, and we're good. So we can create that. We're going to change the name first. Just call it center line. Yeah, that's good. Now we have it there. Boom. Now we can press it. Now we needed the X and Y. Sorry, we needed the pressure, velocity, total, and dynamic. So let's do pressure. There's our chart. Nice. Swap it to velocity. Get the other graph. Move this out of the way. Sorry. Get the velocity one. Now we go total pressure. Where is it? There it is. It didn't click. There we go. Total pressure. Cool. A little more sporadic, but there it is. And lastly, we have dynamic pressure. Cool. Nice. And now we have to do it again with another new surface. Let's make another line. We're going to call this one the vertical center line. And now this, I have the number somewhere because that number is a little annoying. 3048. 3048. Negative. Sorry. Yeah, perfect. And then perfect. That's the whole vertical line. We can create that. And we can close this now. Unselect that. Put the vertical one on. Now we're going to change it up a little bit. So instead of direction vector, we're doing curve length. Get this selected again, sorry. Alright, now for the pressure. There we go. For the velocity, get that there. Total pressure. Nice. And dynamic pressure. Nice. There we go. Those are all ours. That's this portion done. We don't need to do anything else for this. That's that entire thing done. Now we move on to the cylinder. So I'm just going to close this and this. Go back to the workbench. Yes. Work to the workbench. That's one done. Now let's make this one when we open that second, our next one. No, wait till it closes though, because yeah, I don't want to take any chance with that. Add a geometry design model. There we go. Alright. Now we can add a cylinder. Well, a circle. 2D cylinder. Oh, did I not save it? No, you're lying. No. It's just really in there. Because I know it's tiny. It's just a fucking square. Yeah, I don't think it saved it. That's so tough. Alright, it's okay. Zoom out. We're good. Let's just get this done. Alrighty. We can just do it again. I have no problem with this. Get this done. As long as it's done. Now. But it's saved? Okay, now that's just weird. It's saved my stuff. Like, it has all these things saved. I wonder. Because it started off different numbers. I wonder why it didn't just show it. Well, doesn't matter. H8. It's this one. There we go. Oh, wait. What? It was there. Hold on. Wait, that's insane. Oh, I'm saved. Oh, thank the Lord. Alright, we're good. Let's zoom in right there. Perfect. And we get the circle tool. I'm just going to draw it right around the middle here. Just like that. Dimension that. Perfect. And now this needs to be 1/10 of the height, so it should just be that. Make it real tiny. And that's our new sketch. There we go. It all loaded in nice now. Concept, sketches, sketch 1, apply it, and generate. Perfect. Okay, it all worked out. We're all good. That was going to be a little more annoying. Alright, we did it now. We can go start the mesh. There we go. Oh, didn't apologize, I was looking at the wrong thing. There we go. Okay, for the mesh. Same one as before. Method, mesh, make it triangles, and generate. Now, we go over here and we change it right back. And generate it again. Now you just happen to have, the circle in the middle now, but not much else is changing really. There we go, perfect. Got that done. We can now name everything and move on to the last part of this, of the case B, or part B. And we'll just call this cylinder walls. Sure, cylinder wall. Regardless. All right, that part's done. We can move on. Update that. And then let me just close both of these now. We did that. Double. Set that up. Perfect. This one might, for the calculation part, might take a minute, so I'll actually cut it out this time. For the next two, it always takes a minute for some reason. But yeah. All right, here we go. We're in. All right, let's do this. Models, it's loud. Energy, okay. Oh, thank you. Boom, 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 boom. Perfect. Boundary conditions. Velocity, same thing. We'll just keep it at 4. So it's 15 when we get to there. Super fine with that. No problem with that. Now, everything should not be moving. Internal walls and the cylinder especially should be stationary. My bad, that was loud. I don't even know if you guys hear the little, like, warning effects. Stationary wall. All good. Now we can go initialize. I think 10 should be enough, right? I think the last one needed more is what it was. Okay, run calculations. I'm gonna do a couple for this one. So I'll be back when it's done. Okay. Okay, the calculation is complete. So now we can get right back to what we have to do. So I'll go over here. So velocity, pressure contours in the wind tunnel. Zoom in around the circle. Get the pressure coefficient distribution plot on the surface of the circle and the drag coefficient. Okay. We can do that. Let's do it. So for the contours, you go to graphics, like the last one, contours. We're gonna do the same thing. Select everything, and we can just press display. And let me see it. So this is the pressure contours we get around the circle. And then we can do the velocity ones. And this one I think is a lot cooler. But yeah, there you go. How it affects it while it's hitting, it's pretty cool. Anyways, now we can get to the plots. There's only one plot, but regardless, we can get to that. We need to set it to the cylinder walls, and then you need to go, where is it, pressure, and pressure coefficient. Now, I think it works better when you do curve length. And then you set it back to cylinder walls and you plot it. Yeah. I think it's supposed to look more like that. Because last time I would do it in direction vector and I didn't understand that it was coming out right. I didn't like how it was coming out. Like that didn't look correct, but this looks a lot more correct. for sure. Anyways, that's that. Now, for the last part, we need to get the drag coefficient. Forces at the cylinder wall. We print it, and there is our drag coefficient of 2.91. Nice, nice, nice. Okay. Then we get one more situation to go across now. We're almost done. And close this. Yeah, that's good. There you go. Let me go back over here now, and we can continue like we did before. The last one, we have to draw the thin plate now, and we'll be set. Now, I'm going to see if we can make it seen like before. Because it's not showing itself to us. Just can't see it. It's really weird. There it is, and then just, I think it just goes into a really weird level of zoom. Anyways, let's get this done. So I'm just going to draw a rectangle. Sketching. It's a rectangle right here. We're going to constrain it really quick. We're going to give it dimensions. Yeah, we'll do that really quick too. Just those two. And then we're going to go to the constraints. And what I'm going to do this is put it equal to this thing. So it's right there in the middle. And now we can dimension it correctly. So the dimensions I gave it, so for it was H8. So this is just 0.5. That's when we have to give it. But for the to give it the thinness, I just decided to make it like a millimeter because it has to be thin. So I thought a millimeter would work. But I don't know if that affected my numbers or not. So I'm going to try and go a little bit thicker this time. I think a millimeter is just too thin. So we're going to do, instead of 0.1, we'll see how that plays out with the thin plate. So that makes it a little better with calculations. Anyways, that's that. We've done it. We've added the thin plate. Let's just get to it. Concept. Apply it and generate. Perfect. That looks pretty good. Alright, let's get out of here. Go to the next step. First mesh, always do the method mesh. Triangles, generate that. We do the same thing we did for the last ones. Thank you. You guys are also getting the gist of it. My bad. There you go. That's good. Let me generate it. And almost done. Perfect. Now to name the edges. Internal walls. Zoom in here so I can get these. There we go. I got all of them. Plate wall. I'm pretty sure I got the whole thing. Plate wall is all. Oh, did I miss a piece? No, it's red. Just didn't look red. We're good. Okay, Perfect. That's everything done. We can get out of here and get to the last step. Sorry. Thank you. Double this one. There we go. We're going to do the same thing and just look at how that affects the case with the thin plate there. I'm going to have to cut it again so that the iterations run. But it shouldn't take too long. Just going to wait for all this to load. Get started. Alright, same setup as we had before. Perfect. Perfect. Velocity. Right back to 4. And all of these things should be stationary. Okay, let's start this. Initialize. Station. Oh, not reached. Awesome. Let's do 20. Does that reach it? That's fine, discard it. That works. That's good. Run. Was not typing anything. That's cool. There you go. Alright, yeah, I'll be right back. Okay, so calculation's done. Now let's go see what we need to do for this one. So we need to do the same thing: velocity, pressure, contours. Then we need to plot the wall shear and the skin friction coefficient on the surface of the plate and the drag coefficient. Cool, we got that. Let's get that done. So contours. Start off. Graphics. Select everything here. Again. Pressure. Here's our pressure one. Nice. And then we can change it to the velocity contours. Let's at this. Looks pretty good. I like the way that looks. Alright. And now we can close these. Go to the XY plots. And now put it to a curve length. Oh, didn't work with that. That's redirection vector, assuming, because it works there. And they want wall fluxes, and we need it to be, yeah, that one. That's fine. Okay, that should be good. There we go. That is the wall shear stress happening there. And now we need to swap it again. To this. There we go. Skin friction coefficient. And that's it. Well, and it looks the exact same. Both look the same. Pretty interesting stuff. Drag coefficient. Ports. Forces over here. Plate wall, print it, and there is our drag coefficient. Alright, that's all the parts for this. The wind tunnel is completed. Thank you so much. Bye-bye.